In question 6, we're going to build the federal funds market and then show how the Fed targets interest rates. The numbers for the demand curve and the numbers for the supply curve have all been copied and pasted into Excel. Just like in problem 2, the intercept of the demand curve is the sum of C7, which is the shock parameter, plus the product of the reserve requirement ratio, 0.1, and checkable deposits, 521.5. So the intercept is 6.12. The slope is the aversion to holding excess reserves, 0.05. The vertical section is the sum of barred reserves, $0 billion, and non-barred reserves, $78 billion. The horizontal section of the supply curve is the discount rate, 3.22%. So down here we have the supply curve, which is this part of the dashed cross, and the horizontal section here. It's the L shape right here. The demand curve, and then the equilibrium is right here. I've copied and pasted the diagram from Cengage Now here into Excel. The supply curve is the L-shaped part of the dashed cross that starts at $78 billion, goes up until the discount rate of 3.22, and then goes right. The equilibrium federal funds rate is the interest rate at the intersection of demand and supply. The equilibrium federal funds rate is roughly 2.2%. Next, we want to actually calculate the equilibrium quantity of reserves, equilibrium federal funds rate, and the Fed's target for the federal funds rate. The equilibrium quantity is just 78. The target is 1 percentage point less than the discount rate. So if the discount rate is 3.22, the target is 2.22. The federal funds rate is determined by plugging the quantity of reserves into the demand for reserves. And that equals 2.22. So it looks like the federal funds rate is equal to its target. Which of the following statements is correct? The equilibrium federal funds rate equals the target, yes. The federal funds market is in normal mode, yes. So the federal funds market is not in emergency mode, nor is it in crisis mode. So A and B. After the FOMC determines the economy is in an inflationary gap, it will want to raise interest rates to tamp aggregate demand back down to prevent really low unemployment from causing short aggregate supply to decrease, which will result in inflation. So it decides here to raise its target for the federal funds rate by 150 basis points. Again, 150 basis points is 1.5 percentage points. So with the current target set at 2.22%, if the Fed decides to raise the target by 150 basis points, or 1.5 percentage points, the new target is 3.72, and I'll make that red. If it raises the target federal funds rate by 1.5 percentage points, it's going to raise the discount rate by 1.5 percentage points, or 150 basis points. So the new discount rate is 4.72. And I'll make that red to indicate that it's the new value. While the new target is 3.72. Now, when it raises the target for the federal funds rate, it has to do an open market sale. So now we want to compute the size of the open market sale necessary to change the target from 2.22 to 3.72. The open market sale pushes supply of reserves, which is this kink part of this dashed cross, to this kink part of the red dashed cross. I've copied and pasted this into Excel here. So again, we have the initial supply curve, which is at $78 billion. And then you go up until you get to the discount rate of 3.22. The new supply curve is at this value, which looks like it's kind of close to 50, between 40 and 50, but closer to 50. And you go up until you get to the new discount rate, which is 4.72. The difference between this value and that value is the size of the open market sale that is needed to get the federal funds rate to rise from 2.22 to 3.72. To get the value here, we have to set the initial demand curve equal to the new target of 3.72. I got the initial demand curve set equal to the new target of 3.72 here. Then I subtract 3.72 from both sides of the equation, add 0.05R to both sides of the equation, and then divide both sides of the equation by 0.05. So the new equilibrium quantity of reserves is equal to 6.12 minus 3.72 divided by 0.05. So the equilibrium quantity of reserves is now $48 billion. And the size of the open market sale is the difference between $78 billion, the initial level of reserves, minus the final level of reserves, $48 billion. The open market sale is $30 billion. The new discount rate was 4.72, and the new level of reserves was $48 billion. If the excess reserves ratio is 12% and currency ratio is 2%, with the reserve requirement ratio at 10%, the money multiplier is what? The money multiplier is the currency drain or currency ratio, H28, plus 1, divided by the reserve requirement ratio, which is in cell H29, and can be denoted rho or RRR, plus the excess reserves ratio, which is in cell H27, plus the currency drain, which is in cell H28. So the money multiplier is 4.25. The decrease in the money supply is found by making the open market sale negative, because reserves fell from 78 billion to 48 billion, and then multiplying that decrease by 425. So the money supply fell by $127.5 billion. I'm going to check my work and I should get everything but C correct. I leave C to you. And it looks like I got everything correct but part C.